Okay, so chapter 5.3 is all about simple machines. If you recall, a machine is something that is used to make work easier. Now, it doesn't change the amount of work that you do, but it changes the force that has to be applied or the direction that the force has to be applied, and therefore the work is easier for us to do. So there are these things called simple machines, and a simple machine does work with only one movement. There are 6 types of simple machines that we'll talk about today. And then if we combine simple machines, several different types of simple machines into one machine, we can make more complex machines called compound machines. So the first type of simple machine is a lever. So a lever, the definition is it's a bar that is free to pivot or turn about a fixed point. This fixed point is always called the fulcrum, so know that, fulcrum. There are 3 different types of levers. There are first-class levers, second-class levers, third-class levers, and you can see if you look at the pictures that what is changing is the location of the effort force and the resistance force in regards to wherever the fulcrum or that pivot point is. So in these pictures that you can see, the effort, the red, that's where you have to apply the effort force to, and then the green where it says load, think of that as the resistance force. So that's like what we're trying to move or lift or whatever, okay? So some of these classes probably look familiar, like first class levers. If you have ever been on like a teeter-totter at the playground, that's what a first class lever kind of looks like. A second class lever, the fulcrum or the pivot point is at the end and the load is in the middle. The third class lever, the difference between second and third class is that the effort and the loads are switched. And so the fulcrum's still at the end, but now on a third class lever, the effort force is going to be in the middle. We're going to go through each one of these so you can get better ideas of what some examples would be for the 3 types. Okay, so a first class lever, these are going to be things like a seesaw or like a teeter-totter at the playground. Notice that the fulcrum's in the middle. We have an effort and a resistance force, one on each end. If you've ever used a screwdriver to pry like off a paint can, the fulcrum is going, or pivot point is going to be right there where the you have contact between the screwdriver and the paint can. The effort force is over here, and then the resistance is going to be right here. The paint can lid would be our resistance or our load, if you want to call it that. A scissors functions the same way, so you can see the fulcrum in the middle. The effort force or applied force is going to be on one end, and then the load or the resistance force is going to be on the other end where you're actually cutting things. So these are some examples of first-class levers. The fulcrum is in the middle in a first-class lever. A second-class lever is one where you have the fulcrum on one end, and if we can see here, this is a wheelbarrow. So you have the fulcrum on one end, or the pivot on one end. In the middle is going to be our load or our resistance force. And then on the end, on the other end, opposite of the fulcrum, you're going to have the effort force. And so in the middle here is going to be the resistance or the load. So a wheelbarrow is an example of a second class lever. This is like a nutcracker. If you've ever used one of these, the fulcrum is on the very end here, where the 2 ends are connected. The load, because you would put the nut right here in the middle, that's going to be the resistance, and then the effort, your hands hold on to right here and here, and you would be pulling or pushing them towards each other, and so that would be where the effort would be. So here again, the load is in the middle. A car door is like a second class lever because you can see the fulcrum here at the end, where the door is actually connected to the car itself. The load is like everything in the middle. That's where the majority of the weight of the car door is. And then the effort, the handle is always at the other end, opposite of the fulcrum when you're opening or closing a car door. All right, so then third class levers. We've switched what's in the middle. So the fulcrum is still at the end, but now your effort force is in the middle. And then the resistance or the load is going to be at the end. So a baseball bat works like this because the fulcrum is at the end. Right here near the handle. Your hands are applying an effort right here in the middle of the bat, and then the load or the resistance is going to be where you're actually like hitting the ball. Let's see here. A broom, whenever you sweep, is a third class lever because the fulcrum is at this end, sort of where you're holding it almost. That's where it's swinging from or pivoting from. Your hands are usually towards the middle, like high part of the middle of the broom, and you're applying a force there. And then the load is going to be at the very end. The resistance is what you're actually sweeping, so like the bristles of the broom. If you've ever gone fishing, same thing. So the fulcrum is at the end. You are applying a force right here. You're usually holding on to it right there where the reel is. And then the load is going to be like the hook or the fish if you've caught a fish. And so you can see that in a third class lever, the difference between second and third is what is in the middle. In a third class, the effort force is going to be in the middle. Okay, so that's all about levers. That's your first type of simple machine. The second type of simple machine is called a pulley. So a pulley is a grooved wheel with a rope, chain, or cable running along the groove. You've probably seen these before or possibly used them. Typically, they're used to lift things, lift heavy things up. If you think about it, if you're trying to lift something that's really heavy, it's hard to push it up with your hands. And so what a pulley does is it typically is changing the direction of the force, but it could also be multiplying the amount of force that is applied. So we have three different types of pulleys. We have a fixed pulley, a movable pulley, and a block and tackle. A fixed pulley is like this one up here. Oops, let me get my little marker. This is a fixed pulley. The fixed pulley, it is attached to probably like the ceiling, typically maybe a wall, but all a fixed pulley is doing is it's changing the direction of the force. So instead of having to pull something up to get it to move up, I can pull down on the rope here and I can cause the object to move upwards. Notice that the force is the same. We're not changing the force at all. We're just changing the direction that you have to apply the force. And so this weight is going to move up when I pull down on the rope. I pull down with a force of 4 newtons in order to lift a weight that is 4 newtons. And so the amount of force doesn't change, but the direction that I have to pull does change. And so therefore it makes it easier because it's easier to pull down than to push something up. The second type is called a movable pulley. A movable pulley is one where the pulley itself is not fixed, like attached to the wall or the ceiling. It's actually the rope that is attached to the wall or the ceiling, and what it does is it multiplies the force that is being applied. It might look something like this, and these aren't super common, so you can see like this rope would come up here and it would be fixed to the ceiling, and then you are applying this force right here. So if the weight is 4 newtons, like you could see here, you're able to lift it because you are only pulling with 2 newtons up and to the right, but the ceiling is also applying a force of 2 newtons, and so you're actually only applying 2 newtons, but 4 newtons overall is being applied upwards because the rope that attached to the ceiling is also applying that a 2 newton force. And so this will change it changes the amount of force that is applied, and it sort of changes the direction, but you're still pulling upward, and so it's still going to be difficult to pull up. Now, the third type, the block and tackle, can do both things. So it's going to multiply the force that's being applied, but it also can change the direction of the force. And so this is where you would use several pulleys. Some of them might be fixed and some of them might be movable. This is probably more common because if you can see, we have still a weight of 4 newtons. This pulley up here is one that is fixed, and then these other ones in the middle possibly might be fixed or movable depending on how you design the block and tackle. But you can see that you are changing the direction of the force, so you have to apply a force downward of 1 newtons. The block, or this weight at the bottom, is actually moving upward, but because of the system of pulleys that you have, the number of pulleys that you have, you only have to apply 1 newton of force, and so it's multiplying the amount of force that is applied. We're able to apply enough to lift this 4 newton weight, but you're only pulling with 1 newton and you're pulling down, so it makes it easier double in 2 different ways, where it changes the force and it changes the direction. Okay. The third type of simple machine is called wheel and axle. A wheel and axle has 2 different wheels, at least 2 different wheels, and the wheels have to be different sizes, but they rotate together. So some examples of where you would see a wheel and a tackle on a bicycle. We're talking about, let's see, this right here and that right there. Okay, so that's a wheel and axle. You have 2 different sizes of wheels that are moving together with the use of that chain. In a doorknob, in some doorknobs, there is going to be a wheel and axle. You'll have 2 different size wheels that are working to rotate together. If you've ever seen gears before, that's typically how they are designed, is different sizes, and they rotate together. One is always going to be moving faster than the other because they're different sizes. And in a pencil sharpener like the one we have on the wall, we're going to have 2 different size wheels in there, at least 2 different sizes that are rotating together. They're making the work easier. Okay. Next type, the 4th type of simple machine, is called an inclined plane, or very simply a ramp. Okay, so a ramp and an inclined plane are basically the same thing. A inclined plane is going to be a sloping surface that is used to reduce the amount of work or amount of force that is required to do the work. And the reason it does this is because it greatly increases the distance that the force has to be applied. So you apply less force in order to get the object to rise to that height. So if you look at this ramp, it's easier to push this wheelbarrow up the ramp than it would be to just lift the load straight up, because we are increasing the amount of distance that has to be traveled and therefore decreasing the force. Okay, 5th type is a screw. So a screw is actually more common than you would think. It is basically just an inclined plane, so like a ramp, wrapped around a cylindrical post. So we think of screws probably most often as these things, okay? So they're used to hold like pieces of wood together or pieces of metal together. But they are also used pretty much in any screw-off lid. So like a jar of peanut butter, when you twist it off, you can see that inclined plane wrapped around a cylindrical post. So the jar, a lot of jar lids are actually examples of screws as well. If you have ever gone on like in a I don't know, like a parking garage or something where you're like moving around a cylindrical post, that would also be an example of a screw, because it's like an inclined plane that's going around a cylindrical post. Or if you've ever gone like on a mountain, if you're driving up a mountain and the road kind of wraps around the mountain, that would be another example of a screw. Okay, our last type of simple machine is called a wedge. A wedge is an inclined plane again. It could have 1 or 2 sloping sides, but it changes the direction of the effort force. So the most common example of a wedge is probably like a knife. If you cut something, you are wedging the knife between it. What it means by changing the direction of the effort force is that you are pushing down with your with the knife, okay, and the direction of the force, or it changes the direction of the resistance force, the bread splits sideways when you're splitting the bread. And so it takes a downward force, like a vertical force, and changes it into a horizontal force. Your teeth are also examples of wedges. A nail would be an example of a wedge because you're like wedging it between objects, like a piece of wood or something like that. Okay, and then finally, when we put some of these simple machines together, a couple of simple machines together, we get what is called a compound machine. A lot of times we don't use just plain simple machines. A lot of times we are putting them together in order to get something to happen. The use of the two or more simple machines together make different machines that are very common. So think of like a can opener, if you've ever used that. A can opener has several examples. It has a wedge. That's what is going to actually be cutting the can lid off of it. A wheel and axle. It has two different sizes of wheels that are rotating together. And then it also has levers. So it has like a pivot point, like a fulcrum. It has a load and it has a resistance. And so we put all those together and we can make a can opener. Other things that are common, like a scissors. A scissors has, right here on the end, it's going to have a wedge because they're used to cut things. And so when you cut the piece of paper, you're actually making a wedge go there. This is an example of a lever because it has a fulcrum and it has a resistance and an effort force. Let's see, a stapler. A stapler is an example of a lever as well, because it has the fulcrum, which is right here, like on the end. It has the resistance and the effort force. A stapler also, the actual staples themselves that come out of them are wedges because they are like wedging themselves into several pieces of paper. So we put them all together, or we put several different examples of simple machines together, and we can make these things called compound machines.